All right, hello and welcome back to day 2 of our lessons for week 3 involving circles and polygons. If you missed yesterday's lesson was mainly on the conceptual understanding of what is area and what is perimeter. Very important before we get into what we're going to be doing today. So for today, we're going to be focusing on circles, okay? And we're going to derive pi. We're going to do a little experiment, and I'll explain more about that in a second. But for circles, right, you have to understand certain parts of a circle. Again, if you have your paper and pencil, right, this is where you might want to draw this picture and then label the parts of the circle. So there's 3 parts we're going to focus on. Now's where you might want to pause the video and take a little time out to write those 3 parts of the circle. And we're going to define them, so you want to be able to write this stuff down, okay? So again, pausing and, and try and do that right now, and I'll come back and I'll share what these important parts are. Okay, so assuming that you've paused the video and now you're back, here is these parts that we're going to be talking about today that are very important for us to derive pi. Okay, we'll talk about that in a second. But the blue line, right, the first part, that is called a chord. Okay, now what is a chord? All right, if you want to write this down, very important. A chord is a line connecting 2 points of a circle. Okay, so that's a chord. What about the red line? What did you put for that? That is the diameter, okay? The diameter, right? Again, if you want to write this down, the diameter is a line connecting 2 points of a circle through the center, okay? Through the center is super duper important. One can say that it's basically a chord that goes through the center of the circle, okay? And then that green line, what is that? Well, that is the radius. Okay, now what is a radius? A radius is a line connecting 1 point of a circle to the center. All right, so it goes to the center of the circle, but it only touches one part of the circle, okay, from the center. So the other two, they touch 2 parts, right? This one only touches 1, okay? And one can say that the radius is basically half of a diameter, right? 2 radiuses give you a diameter, all right? But let's recap, or let's talk about what is the area of the circle. How are we going to find that? Well, before we do that, let's talk about what we did yesterday, all right? We talked about the area and the perimeter of a square. Now, this is a different square, right? But I could find the area and the perimeter of this very easily, okay? Let's go ahead and walk through that fairly quickly, right? So here, we talked about it yesterday. We can count every one of these little boxes in here, right? And we can figure out what the area is, because the area is the space inside, right? Now, you might be saying, well, there's no need to do all of that, because we also learned yesterday that all you have to do, all right, really sloppy 17 there, but all you have to do is know what the base is and what is the height, right? So the base is 6 units, 3, 4, 5, 6, and the height is 6 units, 1, 2, 3, 4, 5, 6. So we can figure out the area by simply multiplying the base times the height, 6 times 6. And what we'll see is our area is 36 square units, okay? Now, what about the perimeter, right? Well, the perimeter, we talked about it yesterday also, is the distance around the whole entire square. So if that's 6 and this is 6, 3, 4, 5, 6 units, it's a square, so it has all equal sides. Well, the perimeter is just 4 6s, right? Or 6 times 6. But if we add up all 4 sides, we'll see that the perimeter is 24 units. Okay, so we know the area and the perimeter, and it's very straightforward, pretty simple for a square. All right, now what did we talk about? Yes, or what did we do to define it? We said the area is the amount of space inside of a flat two-dimensional surface, and the perimeter is the distance around it, okay? Around the flat two-dimensional surface. So then we say, well, what is the area and the perimeter of a circle? Okay, now you might already notice that, well, this right here, it's a little tricky because, yeah, we got some full squares here, and I can try and count all these spaces in here, but this isn't really half of a square unit because it's curved, right? And it's not really half, and this is almost a square, but not quite really. So we can't just simply count the squares inside of the circle. And then when it comes to the perimeter, well, perimeter, what are we talking about? The distance around? Well, that doesn't really work because it's a curved space here. And so the outside of it, you can't really count units all the way around it. So how in the world do we find the perimeter of the circle? Well, first of all, it's not perimeter, right? When you're talking about the distance around the circle, we're talking about the circumference, all right? So we don't say perimeter for a circle because perimeter is dealing with straight lines, right? Line segments. Obviously, the circle does not have line segments, right? So this is the circumference. Now, we are going to use the circumference. We're gonna find the circumference of this circle, and we're gonna talk about, well, what does any of this have to do with deriving pi? So let's do an experiment, okay? Now, here's what you're gonna need for this experiment, okay? You're gonna need a can or something circular that you'll be able to trace on a piece of paper. All right, you're gonna need a string, you're gonna need a ruler, and some scissors. All right, and what we're gonna do is we're gonna use this experiment to figure out how do we find the circumference of a circle. Okay, so I'm gonna allow you to pause the video now to get these materials. Okay, so you can do this experiment along with me. All right, now let's go ahead and get into our experiment. Okay, so what you're going to do is on your paper, I'm using a dry erase board, okay, but on your paper, what you're going to do is you're going to place your circular object, whether it's a can or whatever it is, on your paper, down like this, all right? I'm going to use my whiteboard, and carefully, I want you to trace around the outside of the circle, all right? So very carefully, right? You want it to be a nice, perfect circle. Okay, so I'm trying to make this as neat as possible. All right, and you should be doing the same. You want it to be as perfect as possible. Okay, so I'm gonna lift that up, and there's my circle. Okay, and if I'm moving too fast, you could always pause the video and and catch up with me. All right. Now here's the second step. What you're gonna do. Okay, you're gonna take your string. All right, and you're gonna place it over the circle, and you want it to be the diameter of your circle, okay? So we're going to use the diameter length to figure out the circumference of this circle, okay? So let's go ahead and do that, all right? Then you're going to make a mark on one end, right where the line crosses, okay? And you're going to cut your string right there, All right, so I'm going to take my string. I'm going to cut it right where I marked it. Okay. All right, and then I'm going to measure, okay, I'm going to measure this string using my ruler. Now, I think it'd be a good idea to use metric units here. All right, centimeters. Let's measure in centimeters. So my string is, all right, as close as possible. It's not going to be a perfect science because the string is going to have to work with us here. But my string, or my diameter, is about 23 centimeters. Okay, so I know my diameter is 23 centimeters. So I'm going to write that down because I got to remember that. So I'm going to put D for diameter equals 23 centimeters. Okay, now I'm going to use that. I know what the diameter is. I'm going to use that to measure the circumference of my circle. I'm going to go all the way around it one time, right? So I'm going to mark a starting point, right? So I want you doing the same, right? You're going to mark an X for the starting point. Okay, then you're going to take your string and you're going to try and wrap it around your circle as best you can. So I'm going to take my string, place it here. I'm going to wrap it around my circle as close as I can. It's not going to be perfect, but you want to try and do it as best you can. All right, so it stops right about here. I'm going to make a mark here. All right, this is my first stop. All right, it's not going completely all the way around. And I'm going to take my string. So far, I know it's 23 centimeters long. I'm going to add more to that by putting my string back on the line, right? You should be doing the same. And again, if you got to pause the video, that's fine. Go ahead and do that, right? But you're trying to do it as close as possible. Okay, so there, I'm going to mark my second mark, right? So each one of these marks is 23 centimeters, right? So I know it's 23 centimeters from the start to my first mark, 23 centimeters from the start to my second mark. All right, so far I got 46 centimeters for your circumference, for my circumference. Now I'm gonna do one more connection here, full connection, I should say. And that right there is another 23 centimeters. I'm gonna mark where my line ended there. All right, and that is another 23 from here to here. All right, and so finally for this last piece, well, I'm not going to need my diameter for that, but what I'm going to do is I'm going to take from my third mark, I'm going to measure it with my ruler. Now this is a curved line, so it's not going to be a perfect straight line, of course, but this is an estimate that we're doing here. And what I measure it to be is 4 centimeters. Let me double check that. Yeah. All right, so from here to here, I got 4 centimeters. Okay, so my circumference, right, I'm going to write this down right here, is equal to 23, right, plus another 23, plus another 23, plus 4 centimeters. All right, so let's add all that up here. My circumference, 23 plus 23 is 46, plus another 23 is 69, plus another 4 is 73. So my circumference is 73 centimeters. Okay? 73 centimeters. My diameter was 23 centimeters, and my circumference was 73 centimeters. All right? Now, what does that have to do with pi? All right, well, it has a whole lot to do with pi, okay? Because, all right, what we're dealing with is basically a ratio, okay? Now, what did we discover? What we discovered is that, well, let's not go too fast. Let's back it up a little bit, right? For me, I discovered that my circumference was 73 centimeters and my diameter was 23 centimeters. And what we learn is that pi, what pi is, it's the distance of, well, it's the ratio, right? Notice that the string went around once, twice, 3 times, right? And then there was this little piece left over, right? And what pi is a ratio of the circumference to the diameter, right? So if my circumference is 73 and my diameter is 23, okay? If I divide those two, okay, let me get my my calculator out real quick. If I divide those two, let's see what it comes out to be. 73 divided by 23, I got 3.17. 3.17, okay? Now, if I had gotten 3.14, that would have been perfect, okay? But mine was 3.17 because, again, it's not an exact science. I'm using a string, I'm cutting it, I'm trying to curve it around, I'm using markers. It's not an exact science, but that's pretty close. I want you to do the same. What was your circumference divided by your diameter, okay? And use your calculator to figure out what is that, right? And what is it going to equal, okay? It should be close, around a little bit more than 3, okay? All right, so now that you check that, let's talk about what pi is by definition. Pi is the ratio of a circle's circumference to a circle's diameter, okay? Now, pi is known, it's an irrational number, and it goes on and on and on and on and on and on and on. It does not stop, but we understand it to be simply 3.14, okay? It is the circumference divided by the diameter, okay? All right, and there we have our abbreviated uh, equation, right? It's also known as 3.14, and it's also known as the improper fraction 22 over 7. If you divided that, you would get 3.14, and it would run on and on and on, and it's understood to be our closest approximation to pi, okay? Now, how can we solve for circumference, right? Well, the circumference, all right, is equal to pi times the diameter, okay? So if I were to do that, let's see, and solve for the circumference, right? I want to isolate the c all by itself. All I got to do is to isolate it, I got to use inverse operations. I'm going to multiply both sides by the diameter, okay? Because the C was being divided by the diameter, I can multiply by the diameter. And what we do to one side, we got to do it to the other. So what we see is the circumference is equal to the diameter times pi, classically known as pi times the diameter. Okay, so that's what circumference is. Circumference is pi times the diameter. And there you have it. Okay, so we can use that in this situation here. We know the diameter of this circle, right? It's the distance going completely across through the center. It's 1, 2, 3, 4, 5, 6 units, right? So we can plug in a 6 here, okay? And then we can use our calculator to multiply. Now, I want you guys using Desmos when you do this, right? If I go to Desmos and if I hit the function button right here, right? Here's my pi button right here, right? Actually, let me clear it first. Here's my pi button. I'm gonna hit pi. Then I'm gonna go back to the main, right? This is desmos.com, right? /scientific, right? And I'm gonna hit times pi times our diameter, which was 6. And here we have it as 18.849, but if I round it, I'm gonna say 18.85. Okay, so my circumference is 18.85 units. The area is pi times the radius. Well, what is the radius? Well, the radius is the distance from the center to the edge. So we have 1, 2, 3 units. So the radius is 3. So I'm going to put a 3 in here. And then again, I'm going to go to my Desmos calculator. I want you guys using the Desmos calculator. Okay. Again, that's desmos.com /scientific. All right, and let's do pi times 3 squared. So I'm going to hit my function button. I'm going to hit pi times 3. And here's my squared button right here. And when I square it, you see the area is 28.27. Okay, pi times the radius squared. So our area is 28.27 square units. All right, so what I want you doing, all right, is for this circle, I want you to find the diameter, radius, circumference, and area. And then I want you to answer this last question. What is the ratio of the circumference to the diameter? Okay, so you can pause the video and see if you can answer these questions. And then I'll be back to see if you did it correctly. All right, so assuming that you paused the video and now you're coming back to check it, what is the diameter? Well, the diameter is all the way across through the center, and it's 1, 2, 3, 4, 5, 6, 7, 8 units. So that's our diameter. It is 8 units long. Okay, what is the radius? The radius is from the center touching one point to the end. It's 1, 2, 3, 4 units. So our radius is 4. Now, what is the circumference? Well, remember the circumference is equal to pi times the diameter. Pi times 8. Okay, so we're going to pi times 8. We're going to use our Desmos calculator to do that. Pi times the diameter, right? So I'm going to clear this. I'm going to hit my function button to get the pi. Then I'm going to go back to my main to get the multiplication symbol. And our diameter was 8. So here we see our diameter is 25.13. All right, so circumference is 25.13. 25.13, and it's a distance around the circle, so it's just units. Okay. Now, what is the area? All right. Well, the area right? And I'm going to use this to kind of do this a little quicker. The area is pi times the radius squared. Pi times the radius squared, okay? So in this case, our radius is what? Our radius was 4. So we go to our calculator, pi times 4 squared. I'm going to clear this function button. Pi, go back to my main, times 4 squared. And there you see is 50.265. We're going to round it up to 27, right? So 50.27 is what you should have had for the area, 50.27. And then our units, it's an area, so it's square units. So we're going to say UN to the second power. Oof, that's a rough 2 there. All right, and then last but not least, what is the circumference to the diameter? Talking about that ratio, comparison of two numbers. Well, the circumference is 25.13, and the diameter was 8. 25.13 divided by 8. Now, what does that equal? Well, let's get our Desmos calculator. All right, so I'm going to clear it again. And I forgot the numbers. What was it? 25.13 divided by 8. 25.13 divided by 8. Divided by 8. And there you see 3.14125. It's not perfect all the way through, but it's definitely good from the to the hundredths place. So we know our calculations are good, right? 3.14, because pi is the ratio of the circumference to the diameter. All right, so that concludes our day 2 lesson. All right, again, you have extra work available on RPS at home if you want to take this a step further. Check in tomorrow as we continue to work on SOL 6.7. All right, talk to you tomorrow. Bye.